Okay, lesson 8.3. We have graphing y is equal to ax squared plus c. So now you can see that we have added the last term. Okay, when we do this, when c is greater than 0, all this is going to do is, if you look at the blue one is our parent function, okay, from basically 8.1. And remember, we skipped 8.2, so we're jumping right into 8.3. So the parent function that you did yesterday, and then if c is greater than 0, meaning that it's a positive number, it will basically shift or translate the parabola up, okay? It will translate it up. If c is less than 0, c is negative, it will basically translate it that many units down. And that will be equal to the absolute value of whatever c is, but it's going to go in the down. All right, and then we'll be comparing it a lot to the parent function when we do this. So let's go ahead and get started. So looking at the example from your textbook, here we have x squared minus 2. Remember, the parent function is x squared. So make your table of values, plot the ordered pairs, draw your smooth curve, then compare them. So the blue one is our g of x, the f of x is our parent function. So you can see that the g of x is below the parent function. So we'll describe it. So they both open up, they both have the same axis of symmetry. The vertex of the graph of g is 0, -2. It's below the graph of f, which is the vertex is 0, 0, because the graph of g is a vertical translation 2 units down. So these might be the types of words and things that I'll be filling in the blanks on big ideas. So let's go ahead and graph. So we want to start with the table of values. Okay, so again, it's easiest if we make about 5 points to graph. It makes it get the curve a little bit easier. So we want to take -2 squared, which is 4, plus 5, and we get 9. -1 squared plus 5 is 6. 0 plus 5 is 5. And you can see that this is where it's crossing the y-axis. It's our y-intercept. Then we'll have 1 plus 5, and then we'll have 4 plus 5 again. So I'm going to go ahead and let's just count by ones, make it a little easier. Draw in our coordinate plane here. And then we'll plot it. So -2 and 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, 2, 3, 4, 5, 6. 0, 5. And then it's pretty symmetrical here. Go ahead and graph it. Okay. This would be our parent function. Okay, 0, 0. So when we look at this and compare it to the parent function, we know that they both open up. They both have the same axis of symmetry, which is x is equal to 0. And then g of x is translation five units above f of x, I guess, or the vertex of f of x. All right, so make sure that you're able to describe that. Well, let's try another. Now we got a little bit more going on here. This time the coefficient of x is not a 1, but the coefficient of our parent function is still 1. So we'll make our table of values. Again, we can -2, -1, 0, 1, and 2. So when we take -2 squared, we have 4 times -3. which would be negative 12 minus 2. So we get negative 14. And then 1, negative 3, so we have negative 5. Here, if we have 0, we would get negative 2. And then this should all work out the same. All right, this time I'm going to, so we're going to be graphing maybe in the 3rd and 4th quadrants of the coordinate plane. So I'm going to move my x-axis to the top. All right. So negative 2 and negative 14. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, woo, off the grid. Negative 1 and 1, 2, 3, 4, 5. 1 and negative 5. I didn't do 0, negative 2. Got to do 0, negative 2. All right. Oops. 1, negative 5. And 2, negative 14. So we're going to have all right. All right. So now because we did it this way, let me change colors here. Our parent function is still right here, okay? So when we're looking at comparing these, we have some things that have changed now. This looks narrower, right? And we have this to think. It's opening down, and that's because of the negative number. So n of x is a vertical stretch by a factor of 3. Let's see, is a reflection in the x-axis, and the vertex is translated to units down of f of x or the parent function. Okay, so make sure that you can explain all of that. All right, so now we're going to solve some real-life problems here. In this problem, first thing we want to talk about is the 0 of a function. A 0 of a function f is an x value for which f of x is equal to 0. So now the output value would be 0. Just like when we solved the trinomial equations where we made them equal to 0 so that we could solve for the variable, there might be some factoring that we need to do. A 0 of function is an x-intercept of the graph of the function. So this is a place where y is equal to 0. It's crossing the x-axis as well. So in this function, it looks like you can see you have a person that's dropping something. Okay, it's represented, the function negative 16t squared plus s sub 0 represents the initial height in feet of a falling object t seconds after it's dropped from the initial height of this s sub 0 in feet. So we have an egg is dropped from the height of 64 feet. So the s sub 0. So f of t is equal to negative 16t squared plus 64. All right. So we want to know how many seconds does it take for the egg to hit the ground. So we want to factor this. So the first thing we're going to look for is a common factor. When I'm solving for part A, I see, so f of x, so we'll have 0 is equal to, because we want to make the height 0, and we would factor out a negative 1. Well, we could factor out more than that, can't we? We could factor out a negative 4, actually. So if we factor out a negative 4, we're going to be left with 4t squared minus 16. Okay, this is a difference of two squares. So we will have 2t plus 4 and 2t minus 4, because this is a special pattern. Now, this example isn't in your student journal. It's in the textbook, but I just thought it'd be better if I explained it before we do any word problems down the road or solving for these zeros. So now we need to solve for t to find our time. And we know that this -4, there's no variable here. So we just divide both sides by -4 and it's gone. So we know that we have basically 2t plus 4 equal to 0 or 2t minus 4 equal to 0. So you're subtracting 4 from both sides. 2t is equal to -4 divided by 2. So we have this t is equal to -2, or we have plus 4 on both sides. T is equal to 2. Since what we're finding is the seconds, this is kind of erroneous. It doesn't really make sense. So it basically takes 2 seconds before it hits the ground. Okay, that would be the height of 0. So if we took a look at what the graph would look like right here, all right, it's really only half the parabola that we're talking about, because this would be the initial height of 64. You can kind of read that on the y-axis. So this is our 64. It's going to fall down like this, and when it hits the ground, it will intersect with the 2 on the x-axis. Okay, you could graph it as well to see for that to work out. Okay, so now suppose the initial height is adjusted by k feet. How will this affect it? Well, think about this. If we take this initial height 64 and we add to it, right? Let's add to it, whatever it might be, add k, right? It doesn't matter. We shift it up, right? What that's going to do is kind of bring that parabola. I could try to like follow, and it will intersect here. So it would take longer to fall. If we adjusted k, right? So if k is, I want to say that greater than 64, or k is positive, right? It would take longer. If it's less, oh boy, I'm not good with these. It would take shorter amount of time. So it's going to change the time in seconds is what it's going to do, and that's how it will affect it. So basically, this one represents k being greater than 0. If it's a positive number, we're going to add to the 64, and then it'll take longer than 2 seconds. And here, this is what happens if k is less than 0, and we subtract from 64. Okay, and it's going to change the projectile of the object and the amount of time it takes for it to hit the ground. All right, so keeping in mind all that, let's find the zeros. So now this is just very much like what we did in our last lesson. The zeros of the function means we're going to make y equal to 0. So we will have 0 is equal to -x squared plus 1. So first thing I want to do, factor out a -1. I'm left with x squared minus 1. Difference of two squares pattern. X plus 1, x minus 1. Therefore, I have x is equal to, we subtracting 1 on both sides, or we'd be adding 1 on both sides. So I should have, not that, I should have an equal sign here. All right, so it's equal to -1 or +1. Why don't you go ahead and do number 6. Please find the zeros of the function. I'm going to move over to number 7. First, I'm going to make it
0 equal to negative x squared plus 64, common factor, negative 1. X squared minus 64, difference of two squares. It's all equal to 0. So that means that we have x is equal to negative 8 or x is equal to 8. Okay, and go ahead and do number 8. So we have to do 2 problems on this page. All right.
Okay, here we are at the vocabulary and concept check. So please select one. Make sure that you are using complete sentences. Let me know which one you are responding to. And then if you have any questions, please be sure to let me know. I will see you in class tomorrow. Have a great night.